Hey math enthusiast, I'm here to continue the notes on the inverse trig functions and solving a right triangle. Let's take a look at this first word problem. We have a 20-foot ladder, it's leaning up against a wall. Base of the ladder is 4 feet away from the wall. I want to figure out the angle that the ladder makes with the ground. So let's sketch out a picture of what's going on here. So here's my wall. Here's my ladder, and here's the distance the ladder is from the base of the wall. I'm going to assume I have a right angle here where the wall is. And now I can fill in some side lengths. They tell me the ladder is 20 feet. So that side, my ladder leaning against the wall, is my 20 feet. Base of the ladder is 4 feet away from the wall. So the base of the ladder is down here at the bottom right, and it's 4 feet away from the base of the wall. So what exactly am I looking for in this case? So I want to figure out an angle. I only have two choices, and it's the angle that the ladder makes with the ground. So that's going to be down here. So you can put a variable in there. You could put x, you could put theta, which I discussed earlier, or you could use alpha or beta, but I'll just stick with x in this case. Now I got to figure out what function I want to use. So it looks like the two sides I'm focused on are the hypotenuse and the adjacent. So in that case, I'm going to go with the cosine function. Now, cosine of angle x is going to be equal to adjacent over hypotenuse. I know to get rid of that cosine, this is where I'm going to use the inverse. So I'm going to end up with x all by itself on the left-hand side, but then I have to take the inverse on both sides. Now, if you want to, you can reduce that 4 over 20 to 1 over 5, and then it looks like x is going to equal 78.463. But I'm going to round that up to the nearest tenth. So I'm going to go with 78.5 degrees, since that's the units I'm using to measure my angle. All right, let's take a look at the next example. Now, for this next problem, I'm dealing with an angle of depression. It's from the top of this 320-foot building to the top of this 200-foot building. And they specifically tell me my angle of depression is 55 degrees, which is marked in my picture. So we can imagine someone at the top of this taller building looking straight out, and then they tilt their head down to look at the top of the other building. What I'm trying to solve for is the distance in between the buildings. So how far apart are these two buildings? So I'm looking for x down here. What I'm trying to look for in these problems is where is the right triangle? I'm going to eventually have to use trigonometry to solve this. So where is my right triangle? So let's highlight my angle of depression, and let's close this up to form a little right triangle. All right, well, let's redraw that off to the side so I can fill in my information. So we were given an angle of depression, 55 degrees in the top left here. What I'm looking to solve for is x, the distance in between the two buildings. Well, that should be the same as the top part of this triangle here. So I can fill in x up top. Now, the problem is if I'm going to solve for x, I need another piece of my triangle. So I have my one angle, I know what side I'm going after. The two pieces I haven't used yet are the heights of the building. So the taller building is 320 total. The shorter building is 200 total. Well, the one piece of the triangle that I could use would be that height on the right-hand side. So how much taller is the tall building? Now, you could probably just do this mental math real quick, but if the tall building's 320, the short building's 200, then it is 120 feet taller. So now I can fill this in on my right triangle. Okay, So I should have enough information. I'm given the opposite side, and I'm looking for the adjacent in my right triangle. So it looks like the function I'm going to use is tangent. So we'll start with that, fill in our angle of depression, 55 degrees, and it's going to equal opposite, which is 120, over adjacent, which is x. My variable is in the second part of my ratio, or the denominator in this case. So I'm going to switch those two to help me solve for x. So it should be 120 divided by tangent 55. First, we'll change that tangent of 55 into a decimal, which will give me 1.4282. And lastly, I'll plug that into my calculator to find that the distance in between my two buildings is 84 feet. And technically that is rounded to the nearest tenth, so it comes out to be a whole number. All right, let's take a look at this last example. So for number 7, we're dealing with this hot air balloon that is 600 feet up in the air. And there are two people down at these two separate points, B and C. Now it looks like in part A they're telling me there's an angle of depression from your line of sight to person B is 30 degrees. So if you're up in the hot air balloon looking down at person B, this angle formed right here would be 30 degrees. Now what we're trying to figure out is how far is that person from the point on the ground below the hot air balloon. So what we're looking for is the distance from this point to this point. Now, if that person standing on the ground looks up at the hot air balloon, that angle of elevation is going to be the same as the angle of depression. So what I could focus on is this right triangle I've highlighted in blue. So let's sketch that out off to the side. So in my triangle we have an angle of elevation of 30 degrees. I know the height of the hot air balloon is 600 feet. And the point that they're asking for, or the distance that they want, is how far from that person at point B to that point directly below the balloon. So that's going to be my x, or my variable. So in this case we have the opposite side. I'm looking to solve for x, which is the adjacent. So the trig function I'm going to use is tangent. So in this case it's going to be tangent of my angle of elevation, 30 degrees, equal to the opposite, 600, over the adjacent, x. In this case my variable is in the denominator, or the second part of my ratio. So I'm going to use that shortcut, switch these two to get x by itself. So x is going to be equal to 600 divided by tangent of 30 degrees. Before I can plug this into my calculator, I'm going to change that tangent of 30 degrees into a decimal, which gives me 0.5774. So the distance from that point directly below the hot air balloon to the person at point B is going to be 1,039.1 feet. So now let's fill that in our picture. Now for part B, that angle of depression has changed because now I'm looking down at the person at point C. So now that angle of depression here is 20 degrees. Now I can use the same logic I used in part A and think about the person at point C looking up at the hot air balloon. That angle of elevation is going to be the same. It's also going to be 20 degrees. So now what they want to know is how far is that person from the point on the ground below the hot air balloon. So from this point in the bottom left to point C. So once again, let's highlight this triangle and let's draw it down below. So I'll fill in what I know. Angle of elevation is 20 degrees with the person at point C looking up at the hot air balloon. That is 600 feet in the air. What I'm looking to find is how far is that person from that point directly below the hot air balloon. So this problem is very similar to the previous one. I have the opposite side. I'm looking for the adjacent side. I'm going to be using the tangent function again. The only difference is this time around, my angle of elevation is 20 degrees. Opposite is still 600, and adjacent is still x in this case. Variable is in the same spot, so I'm going to use my shortcut again to solve for x. So I know x is going to equal 600 divided by tangent of 20 degrees. So first let's change that tangent of 20 into a decimal, which gives me 0.364 when I round it. So finally, when I plug that into my calculator, I end up with 1,648.4 feet. Now I can fill that into my picture as well. Now the last part of this question, C wants to know how far apart the two people are. So how far is it from point B to point C? Well, the total distance from the person at point C to that point below the hot air balloon is 1,648.4 feet. And I'll subtract the distance from that point to the person at point B, which gives me a total distance of 609.3 feet.